Hello, my name is Samuel Kundi, and I'll be presenting my Lab 2 magnetic field of a bar magnet. So the purpose of this lab was to determine the relationship between the magnetic field and the distance on the axis and off the axis. I had to use an app and a bar magnet to find the magnetic fields as part of my observations, which helped me understand the various relationships involved. I then used the starter code and uploaded to GlowScript to edit the GlowScript code and model my observations. The fundamental principles that were vital for this lab were Biot-Savart's law, magnitude of the magnetic field, and magnetic dipole moment. So for the procedure of this lab, I first downloaded a magnetometer app on my smartphone, and then I determined the direction of the magnetic field pointing north. In other words, I had to make sure that the X value was around zero or close to zero to help me start off this experiment. I then used a meter stick and placed it perpendicular to the north, and then I placed a bar magnet at the end of the meter stick. I then moved my smartphone along several locations on the meter stick, and I noted the distance between the bar magnet and the magnetometer. And so I uploaded my data to an Excel file, and I was able to get these values. I got my equation to be y equals negative 3.0073x minus 14.397. And based on that, the graphs from the Excel, my average D perpendicular was 0.187, the N value was negative 3.0073, and my mu value was 2.795. And so, as I said earlier, I used a starter code and uploaded to GlowScript, and I edited some key values. First, I edited, of course, the mu magnitude, which is, of course, 2.795. I also edited the function for the magnetic field, as you see, from lines 32 to 36. I also edited the lines for the two on the axis for perpendicular to the axis. So that's lines 56 to 61. And I also had to edit the two arrows to represent the magnetic field on the axis. So as you can see, I edited for axis 1 and for axis 2. I then edited and added lines to represent the magnetic field perpendicular to the axis, and these were represented with 4 arrows. And then I edited of course, the D perpendicular to be, of course, 0.187, as well as edited the magnetic field 45 degrees from the axis to help edit an arrow to represent that value as well. When I ran my code, I was able to get the B at 45-degree distance at D equals 7.55583 times 10 to the negative 6, 2.26675 times 10 to the negative 50. And I guess based on personal errors, yeah, I guess one of the problems could be I had trouble lining up my phone, or the calculations may have been altered because I didn't place my phone correctly as I moved it along the meter stick, and just maybe based on how I placed the bar magnet at the end of the meter stick. And so for the what if in the experiment you oriented your setup so as to compensate for magnetic north? What if you hadn't done that and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? Well, the values would have been skewed, and as a result, the values would be less accurate. And another what if, imagine if you had two identical magnets. What if you redid the experiment, but instead of using a single magnet, you used the two identical magnets stuck together end to end? How would you expect your measurements to differ? Well, the direction of the magnetic field would still be the same. However, the value would be higher.